Okay, we're going to get started with Chapter 7, our last chapter of the year. And we're actually going to start this with Section 2.3, which is about circles. We had skipped this when we did Chapter 2 earlier in the year. And the reason we do this is that Chapter 7 is about trig functions, and trig functions are based on the unit circle. So before we can do trig functions, we should know about circles in general. So, getting started with 2-3 circles. First objective. We're going to write the standard form of the equation of a circle. So what's the equation for a circle? Alright, before we do that, we need to know a couple things about a circle. A circle is a set of points that are a fixed distance r, which is the radius. That should be pretty familiar, from some fixed point h comma k, and h comma k will be the center of the circle. So here it is. The standard form equation is x minus h, y minus k, and r squared. Alright, these minuses should be familiar from our x and y intercepts, finding zeros. And if we have the center at the origin, we would have x minus 0 and y minus 0, so we can write those as just x and y squared. Alright, now here's what we're talking about for the unit circle. That's if you have a origin center and you have a radius of 1. And the unit circle we're going to use a lot when we get into trig functions, both this year and next year in pre-calculus. Okay, so let's try a problem. Write the standard form of the equation of the circle if we're given the radius and we're given the center. So let's start with the radius. R squared, so 4 squared, so that turns into 16. X minus RH, so x minus negative 5 squared. So x plus 5 squared plus, and then let's deal with the y's, y minus 2. So we can put that right in, y minus 2 squared. And there's your standard form. X plus 5 squared plus y minus 2 squared equals 16. This circle has a center at negative 5, 2, and a radius of 4. Alright, try problem 7. Second objective, let's graph these things. So, we're going to graph it by hand first. Give myself the coordinate plane. I'm going to go to negative 5. I'm going to go to 2. And I'll put a little dot there for the center, but that's not where we're going to draw our circle around. We have a radius of 4. So what I'm going to do is I'm going to go over 4 to the right. I'm going to go over 4 to the left. I'm going to go down 4. 1, 2, 3, 4. I'm going to go up 4. Now, my tick marks aren't perfect, so this is a little more rectangular than it is a perfect circle, so it's a little bit more of an oval. But what we have here, this is the bounding box of the circle. The circle is going to be contained within that bounding box. It's tough to draw a circle with the pen on the computer here, but you get the idea. On your piece of paper, draw a prettier circle than that, but here's your center, and the radius is 4 in every direction. Alright, try problems 23A and B. Okay, what about finding the intercepts of a circle? So, for this one, let's see where it crosses. Now remember, for intercepts, if we go back here, the intercepts are where we cross an axis. So you'll see here, we're not going to have any y-intercepts. It never crosses the y-axis. We will have x-intercepts, and they're not going to cross at nice, pretty places usually. So we're going to have to figure these out algebraically. Let's start and prove that we don't indeed have any y-intercepts. So we would make x 0. So 0 plus 5 squared is 25, plus y minus 2 squared equals 16. If we bring the 25 over, we'll have y minus 2 squared equals negative 9. And to get rid of that squared, we would have to square root. And right away, we do not have any real intercepts. So, no y-intercepts. Let's try the x-intercepts. We'll make y 0. So, x plus 5 squared plus negative 2 squared is positive 4. Negative times a negative is a positive. Equals 16. Move that 4 over. X plus 5 squared equals 12. So x plus 5 equals plus or minus root 12. You could pull a 4 out, so 2 root 3. And so the x-intercepts are going to be at -5 plus or minus 2 root 3. All right, go ahead and try problem 23C. Okay, let's work with the general form now of the equation of a circle. And what we have here is x squared plus y squared plus ax plus by plus c. So everything is pushed onto one side of the circle. That's the general form. The general form is not very helpful for graphing. So mostly we want to take our general form and move it back into standard form so we can graph it. So let's go ahead and do that. I'm going to group all my x's together. X squared plus 10x. And I'll leave a little space in here, and you'll see why in a second. Plus y squared minus 4y. And I'm going to push that 13 onto the other side. Alright, so we're starting to get closer to what the standard form looks like. Let's complete our squares. Half of 10 is 5. 5 squared is 25. If I do it on one side, I need to do it on the other. Half of -4 is -2. -2 squared is 4. If I do it on one side, I need to do it on the other. Let's see what we've got. This is x plus 5 squared plus y minus 2 squared equals -13 plus 25 is 12 plus 4 is 16. That should look awfully familiar. It's that circle we've dealt with before. All right, try problem 27 and oop, I thought we were done. One more. Try problem 27. All right, finding the general equation of a circle. Find the general equation of the circle whose center is at -2, 3 and contains 1, 4. All right, so we know that we are at, let's start with our standard form here. X plus 2 squared plus y minus 3 squared equals r squared. All right, we would be in business if we knew what the radius was, but unfortunately we don't. But what we can do is we do know some x number that's on the graph. So let's plug that in here. 1 plus 2 squared plus, and we know a y number, 4. 4 minus 3 squared. That's going to be your r squared. So 1 plus 2 is 3, and 4 minus 3 is 1. 3 squared plus 1 squared is 10, so 10 equals your r squared. Now you're tempted to square root that, but we actually want the r squared for our formula. So we're done. X plus 2 squared plus y minus 3 squared equals 10, which is what your r squared is. We need a number for h, we need a number for k, we need a number for r squared. All right, try problem 13. All right, that'll do it. Any questions? Make sure we go over it in class. Good luck with those problems.